here we are at the end of Unit 8, and there's one more interval formula to cover for the chapter, and that is called the Bootstrap Confidence Interval. And before we actually talk about the Bootstrap Confidence Interval and their advantages and disadvantages over the other formulas that we've learned, we need to first of all talk about what a Bootstrap sample is. According to what I wrote here on the worksheet, a Bootstrap sample is a sample that is formed with replacement, and that sample comes from another sample. And one thing that's special about a Bootstrap sample is it has to be the same size as the original sample. There are thousands upon thousands of Bootstrap samples that we can create, but let's start by just finding one. So in these directions here, it says that we're given a population of all students in the school. And we're trying to figure out what percentage of the students in the entire school own an iPhone in particular. So to get an idea, we take a very small sample of only 10 students. We randomly select them from the student body, and the N's represent no, that they did not own an iPhone, and the Y's that they did, that it was a yes that they owned a phone, an iPhone. So this was our original sample, and from that sample we're going to take bootstrap samples. So a bootstrap sample would be randomly selecting 10 of those 10 students with replacement. That means that a student can show up more than once in a bootstrap sample, and that's exactly what happened when I used my graphing calculator. And I created this bootstrap sample by using the random integer command. So I chose math on my calculator. I went to the PRB menu for probability and found the random integer command. And when you type it in with 3 numbers after it, like I did here, it's finding a random integer from 1 to 10, and it's finding 10 of those numbers. So these student numbers here make up my bootstrap sample. So let me clear this out of the way. Let's take a look at the students that I got. So my bootstrap sample has Ian, he's number 7, and Ian was a yes. He actually had a iPhone. And Amy is number 2, and she was a no. 5 was D, and D was a yes. As it turns out, 9 showed up in the sample 3 times. Ty showed up in the bootstrap sample 3 times, so he was a no. I'm noticing at 4, Cal shows up twice, and he was a no both, of course. Bo was a yes. And 7, we already had 7 already. It was Ian, and Ian was a yes. So my bootstrap sample has 4 yeses out of the 10. So the bootstrap sample had a sample percent of 4 out of 10, or 40% owning iPhones. Alright, so at this time you can pause the video and you can complete 1 and 2. Find your very own bootstrap sample and then figure out the percentage from your sample. Okay, and you can unpause the video when you're ready. And here's the rest of the story. So question number 3 says repeat questions 1 and 2 once more, and I did that as well. I did another random integer from 1 to 10. I actually have the graphic right here. I repeated the process again and created another bootstrap sample. This time I got student 10, who was Walt. I got him to show up 3 times, and that's 3 no's. Student 6, that was Nina, and she was a no. Student 7 showed up twice. That's our good old buddy Ian. And then 9 was Ty, and he showed up a couple times this time. And then 5, D was a yes, and 4 is Cal is a no. So on this particular Bootstrap sample, I have a sample percent of 3 out of 10, or 30%. So 40% the first time, 30% the second time. So I need you to do that one more time as well. So you have 2 sample percents as well. And once that's done, we can move on to question number 4. Now question 4 is what we've been waiting for. We've been waiting to create a confidence interval that will help us predict the percentage of the school that own iPhones. And in order to get to the formula here, the Bootstrap interval formula, which is very simple, we need to actually have many more Bootstrap percentages. And so far we only have 4. We have the 2 that I had, 0.4 and 0.3, and then the 2 that you came up with. So let's actually write all these down under list 1. So under list 1 you're going to have 0.3 on your calculator, 0.4, those are mine, and then yours. And in question 4, having 4 Bootstrap interval or 4 Bootstrap samples isn't enough. We're going to need, as many as we can get our hands on. So as it turns out, I have, I think, 27 ones from last year. Let's see if it's saved on my. Oh, there it is. They are saved up here. So let me just get those. So bibbidi bobbidi boo. Here are some more numbers to add to our list. So type those into list 1 as well, which brings us up to a total of 31 numbers. And my 31 numbers are going to be slightly different than yours because I don't know your results here and here. But once that's all done and typed into list 1, we can actually take a look at the statistics using 1var stats, and we can get 2 of the numbers that we need for this formula. We need the statistic and we need the standard error. And we get those right off of our calculator. So x hat in this case represents the average of all the percents, and the standard deviation represents the standard error that we're looking for. So take those 2 numbers and place them into the formula, and you've got yourself, well, you're just one small step away from getting your confidence interval. So the only missing ingredient is our z-score, and it's just like we've been doing, using 90%. You looked that up on the table as 1.645. You may have memorized that by now, and that ends up giving us a margin of error of about 26%, and our confidence interval would be between about 15% to 67% own iPhones, which is a pretty wide looking interval. So in question number 5, it asks you to write down a summary of what we did and why it was done. So we created Bootstrap samples from an initial sample, and we did that over and over again, over 30 times, to create a what appears to be a graph that is approaching a normal curve. If you think back to when we did the central limit theorem, if we did this over and over again and didn't just do it 31 times but did thousands of times, we would actually get something that appears to be very normal, and that would be called the sampling distribution. And because we actually have something that appears to be very, very close to the sampling distribution, we can use z-scores instead of t-scores to determine the confidence interval. And that's a brief explanation of why that formula works the way that it does. So let's take a peek at this by using a website instead of using the graphing calculator, and instead of actually relying on classmates to help us out, we can actually use technology to create these Bootstrap samples. And there's a couple websites that I need you to go to accomplish this, and I'll illustrate on the next slide. Well, before we get on with some more math and looking into the website, as you can see in the bottom of the screen, I've got some screenshots ready for you to take a look at. Before we get on to that, I know the very first time I heard about Bootstrap samples and Bootstrap intervals, I started thinking to myself almost immediately, what does it have to do with boots? And fishing around on the internet or from a textbook, it gets its name from the phrase pulling yourself up by your own bootstraps. And maybe you've heard of that expression before. It's an old-time expression. And if you actually ask someone for advice, they'll say, well, you're going to have to pull yourself up by your own bootstraps. So that means that they're telling you basically that you're the one that's responsible for actually lifting yourself up, and you're the one that's going to have to actually solve your problem. And if you're looking for some help from any other resources, there's only one way to look, and that's in the mirror in terms of actually getting your own help from yourself. So that's the flavor of what a Bootstrap sample is. It's creating a sample from your own sample. So you're actually not looking beyond what you've got. You're looking at the only thing that you have, which is your own sample, and you're creating more samples from that. Well, moving on to question 7 and the rest of this instructional video. In question 7, it says to determine the Bootstrap confidence interval to estimate the average price for a Ford Mustang car. To save time, we're going to use preloaded data and also a computer to create over, well, it shouldn't say bucket samples, it should say Bootstrap samples. So we're going to create over 10,000 Bootstrap samples instead of just 31 like we did on the previous page. So I'm going to show you how to use the website, and you might want to pause the video and toggle between the video and the website itself. So typing into the browser that location on the internet will bring up the screen right here. And you won't even have to change the data, because it's all set up automatically with the Ford Mustang data typed into it. So on this menu item here, this pull down menu, you can change from one set of data to another, but we're going to stick with the Mustang price. If you click on show the data table, it'll actually show you the list of all the prices for the Ford Mustangs, and you can actually scroll up and down that list if you want to, but do not change any of the numbers that are there. You can click on that X to X out of that, and then that'll bring you to this screen again. And what we'll do is generate a Bootstrap sample by clicking generate one sample. Taking a look at the right hand side of this website, this has the 25 cars that are in the list, that are actually in the list, and it shows you that the average from the 25 cars themselves is around 16,000. When you clicked generate one sample, it actually plotted it here and actually showed you what the sample looked like. The Bootstrap sample looked like right here. From there, one sample is not enough really, that 1 point estimate, so we're going to actually generate some more. So next I need you to click is generate 10 samples. And of course the results that I'm getting are probably going to be different than yours because this is randomly generated. So when I clicked generate 10 samples, it actually plotted 10 different samples. And then the last sample that it generated is listed here. But now we actually have 10 samples. And 10's fine. But you know what I like more than 10 is I like thousands upon thousands of samples. So we're going to create more and more Bootstrap samples by clicking this. And when did I stop? I stopped actually when I hit 11,111. So very similar, but much more improved is our histogram, which actually looks very normal. And the two important numbers that you're going to need to use are right here. In fact, those are the only two numbers, along with the z-score, that you'll need to finish the confidence interval. So we're relying on the website to do all the work for us. What I need you to do is communicate to me that you are doing a Bootstrap sample, but before we get there, first of all, a condition check. Is it a simple random sample? And it's yes. The original sample was a simple random sample from the original sample. And that's actually the only condition check that you need. The second step is to tell me what interval you're using, and you're using a Bootstrap interval. You could also write down the formula that's there. And we're just going to be plugging into this formula using those numbers that are right there. So we need to know the average of all. The statistic here is the average, which comes out to be 15, well basically 16 right here. And the standard error is about 2.2. So 16 and 2.2 are the numbers we'll need. So we're going to write 16 plus or minus the z-score times 2.2. And the z-score here doesn't say what level to use, so let's choose a confidence level like 95. Looking up 95 on the table, or maybe you memorized it as being basically 2. And then all we have to do is calculate that. So 16 plus or minus basically 2 times 2.2, which is 4.4. So the average price for a Ford Mustang would be estimated somewhere between $11.6 thousand to $20,400. And then the third step, just like the third step for the entire chapter, the method used finds well, here we're looking for the average price 95% of the time. So let's take a quick look at some of the advantages and disadvantages of this strategy. Disadvantages. Well, let's think about what could be in our way of using a Bootstrap interval. Well, one disadvantage is you can't do this without a calculator, or especially the website. I mean, a calculator is nice, but you're going to need thousands and thousands of samples. So the biggest disadvantage I can think of is you would actually need a computer to actually do this, or the website. But guess what? Websites very easy to get to, as long as you have some access to the internet from local Tim Hortons, or maybe have it in your school or your workplace. What's the advantage of using this strategy? Well, one huge advantage to it is it doesn't require a lot of training, really. Just typing in the information into a website and going for it. Another advantage is maybe you didn't even realize it, it is the same formula for whether you're using proportions or averages. It's the statistic from the website plus or minus the z-score times its standard error that comes from the website. So it's the same formula regardless if you're using proportions or averages. All right, and that brings us up to the homework assignment. For the homework assignment, you're staying on that website, but changing the data set from Mustang price to Atlanta commute times. So you're going to have to go to this pull down menu here. Oops. This pull down menu here and change this to the Atlanta commute times, and run through the generation of thousands and thousands of samples. Take those numbers and complete the confidence interval. For question number 2 on the homework, it has you switching to another website. It looks very, very similar to this one. But this website allows you to look at information that is involving proportions. So this is for you to explore it yourself, but when you switch to the website, it'll say something about mixed nuts here, and you're going to change that to the online dating information, and you're going to, again, generate thousands of samples, create those 2 numbers there, and complete the confidence intervals relying on the website. It does seem like cheating, but this is how statistics can be done since computers are available to us. So good luck on completing those 2 questions, and we'll be in touch.